Okay, let's go ahead and get started. Hi, everyone. Good morning, good afternoon. Welcome to Avi's Edge webinar series, part three. What's new in the latest Avi and AKO releases? Um, just a reminder, the recording and slides will be available after this session. I will send out a thank you for attending email, so you'll get all the goodies there. It will also be available on our SRC page and our webinar page in the on-demand library. Um, This is the last part of our Avi's Edge webinar series. Like I said, you can watch part one, part two in the on-demand library. And with that, I will kick things off with Abhinav.
Thank you, Teddy, and good morning, good evening, good afternoon to everyone. Uh, and welcome to the part three of this webinar series, Avi's Edge. Uh, just a quick introduction. My name is Abhinav Modi. I'm a product manager with the Avi Load Balancing team at Avi Load Balancer team at Broadcom. With me, I have Chris. Chris, why don't you introduce yourself quickly?
Yeah, hello everybody. My name is Chris Grice. I'm also a product manager with the Avi team. Good to have everybody on today. Thank you.
Great. So we have a packed agenda. We made some announcements in the recent VMware Explore around some features and innovations on Avi. What we're going to do is talk quickly about Avi to level set and baseline folks who are new to the load balancer. We'll talk about some key features which are there in the recent release in the recent release, the Avi controller 3121, and then the container ingress releases AKO and AMKO. And we will have time for Q&A. So please do, uh, be interactive. Ask your question either in the QA panel uh, during the session or at the end. Okay. So with that, let's get started. Uh, what is Avi? Avi is a load balancer which was founded in 2014 and is part of the Broadcom's application networking and security division portfolio. When Avi was founded, the challenge which the industry faced was that legacy load balancers, whether it is a hardware appliance or a virtual appliance, had a very monolithic form factor. With that, both the control plane as well as the data plane was combined, which caused a few issues, as mentioned over here. One, from a configuration perspective and management perspective, each of these had to be configured, operated box by box. So when you have massive scale in terms of your applications, you need tens or hundreds of these appliances to be able to do provide application delivery to your applications. Second, these are all fixed scale. So as your traffic grows, you don't have an elasticity in the way that these operate and extend. You would have to buy additional hardware or instantiate manually another pair of load balancers. And finally, the visibility which a load balancer, which is sitting in between your network and your application provide, has typically been missing. So what Avi did was Avi provided a more modern load balancing architecture, which is completely software defined. We're a software only load balancer built for private cloud environments. What we did was we decoupled the management and the control plane, which is something which is quite obvious now. If you look at the compute where vCenter and vSphere, vCenter provides the management capabilities to the ESXi hosts. So with that, what happened was that we have a controller which can be used for centralized policy, for configuration. The data plane itself is orchestrated by the controller. So the controller will actually spin out and spin up load balancing entities, which we call service engines, on demand as required. So when your applications grow, when your needs grow, the software-based control plane will deploy software-based service engines in your VCF estate. And finally, the application visibility part is something which we will see in one of the demos as to how we have been able to provide a very good uh, set of analytics as well as application logs to provide troubleshooting information both for application owners as well as for the infrastructure owners. So with that, finally, what I would like to close this very quick introduction with is that the VMware Load Balancer is the industry's first and only software load balancer tailor-built for private cloud environments. And you'll see that as we go along. For more details about Avi and the architecture, do look at the resources slide or go through the previous two webinars in the system in the series. So coming to what are the capabilities and features we provide at a high level. As you can see on the left side, we provide both local or server load balancing, which is the bread and butter of load balancing or proxying, with, of course, SSL termination, SSL offload, as well as SSL re-encryption, and a bunch of layer 7, layer 4 features as needed for your applications. We provide DNS-based or global server load balancing if you have multi-site environments. So those can be very well solved by the same load balancing system. We provide container ingress, and we'll talk about that more. But Avi is the best-in-class container ingress as well, along with Web Application Firewall and bot management and detection to secure our applications. And finally, the latency analytics which we provide has been a key driver for some of our customers to appreciate and adopt our load balancer. Another key thing to note is that all of this comes in a single package. So you don't have to have multiple SKUs, multiple appliances to benefit from these. It's a single software form factor. You can just use all of these from the same control plane and meet all of your needs. So with that, what are the benefits to you as a customer? What we've seen is that Avi provides 90% faster time to deploy a load balancer because of the fact that it is all completely automated. This results in 43% lower operational cost overall, and then up to 27% high developer productivity because you can offload these flows to software-defined teams, to our DevOps teams and your application teams. And this is not us talking. This is being done by third-party customer interviews who have deployed Avi and have benefited from that. From a scale perspective, Avi has large-scale deployments. These are all per site numbers. So 40,000 plus VMs have been load balanced. We can have 15K plus 17,000 VIPs or virtual services on a single controller. We have 9,000 GSLB services for DNS-based load balancing, and then more than 3,000 or 2,500 or close to 3,000 applications looking at solving WAF. And then if you have a multi-tenant environment, we have customers running 1.5 thousand plus application tenants on the same control plane. So fully tenant-based, fully role-based, RBAC-based for all your requirements. Right, switching gears, as you know, VMware and Broadcom have been working through the new VCF stack, which is the VCF 9.x. And what Avi provides is the only and full stack integration for private cloud along with VCF. So VCF has these four concepts or four pillars. One is around building and operating your private cloud. And over there, as you build that private cloud, you start onboarding applications. Avi is built into it to be able to, via VCF operations, to be able to deploy Avi in the VCF infra, do automatic lifecycle management, certificate rotation, all of that stuff, as well as easier deployment once you do VCF import. So that is on the infra part when you deploy a new private cloud with VCF. When you start consuming, or your application team start consuming that goodness of VCF to deploy applications, that is where they will use VCF automation. And over there, Avi is integrated as a self-service with a self-service catalog. So you can use VCF automation to instantiate the load balancer along with your application. And with that, you also have the capability to do LB as code, if you would so want to do that, given that Avi is completely automated, completely REST-based, and has all the features available first as a API and then as a UI. And finally, from a protection perspective, applications today are prone to multiple attacks. Even if it's an internal application, there are cases where things like ransomware or malware can stay undetected for a while, and then it propagates or becomes active. So for that, we have Web Application Firewall, DDoS bot detection, as well as some API protection features, which you can use again on the same form factor with a click of a button to enable along with the load balancing services. So this is a unparalleled sort of deployment and integration which we have with VCF, and we continue to build that along with the VCF journey. So coming to the Avi 31.2.1 and the AKO 2.1 releases, why should you care about that, and why does it matter for VCF deployments? One, these releases build out a bunch of features and performance enhancements. We'll go through that. Second, from a security and resilience perspective, we have a bunch of features which enable you to use best-in-class protocols such as PQC or quantum cryptography. We have added ways to enable your WAF journey, to enable WAF more easily, and then just manage the control plane and the Avi control plane in a better way. And finally, on the container ingress, Avi has been leading in terms of the gateway APIs as a new method to instantiate your container ingress. And we have made significant improvements on that front in this release. Talking about container ingress, last week around Wednesday or Thursday, there was interesting development in KubeCon Atlanta. And Chris was there, live over there in person, going through that. So, Chris, why don't you share some more details about that?
Yeah, thank you, Abhinav. So yeah, this was a interesting session at KubeCon last week on Wednesday, running Ingress Nginx. So Ingress Nginx, if you don't know it, is probably one of the most common, if not the most common, Ingress controller that's out there. It comes by default in a lot of the public cloud offerings. It comes by default with Rancher. It comes by default with a lot of Kubernetes offerings. And the interesting thing about it, it was maintained by two guys. And fundamentally, these two guys have said, look, we can't do this anymore. Nobody else is stepping up to the plate. So what they're doing is they're archiving the Ingress Nginx project. That's happening in March of 2026. And what this means is there's no security patches going forward, no bug fixes going forward. And so, of course, what this means is everybody, especially enterprise-grade customers, are going to have to migrate. They're going to have to migrate to some other Ingress controller. And so, when you look at where Ingress is today, and, Abhinav just mentioned Gateway API as well, the Ingress API is actually frozen, so it's not going to change anymore. So what we're seeing here is we're seeing this as an opportunity to, kill two birds with one stone. And what you can do here is you can come to an enterprise-grade load balancer. You can migrate from Nginx to Avi, and we'll be providing some support for that. And at the same token, move to Gateway API as well. So you can kind of future-proof your Ingress deployments, and you can move to a sort of best-in-class Ingress controller that has full support, leverage Gateway API, and then not have to worry about sort of this happening again in the future. So it's just a kind of interesting segue. It kind of points to, open source is fantastic. It really is good. Don't get me wrong. But if you're running Kubernetes for the enterprise, it's perhaps not the way forward. And this is the reason why. Yeah, thanks, Abhinav.
Yeah, thanks, Chris. And we'll get into this a bit more detail as to what features we provide after we go through the Avi releases. So let's get into the Avi release features first, and then get there. So for Avi 31.2.1, these are the three main themes which we are looking at. One, the private cloud and core enhancements, the core features. Two, security features. And then three, resiliency, both in terms of the control of the system as well as your applications. So let's go through these features one by one. And by the way, this is just a snapshot of the features which we have, the key ones. There are a bunch of things. Please go through the 31.2.1 release notes and the content, and you'll find a lot more goodness over there. Let's start with the first one, the Avi Quick Start Wizards. So Avi has been, currently provides a bunch of features, very versatile, very flexible across multiple cloud environments. For example, when I say cloud environments, even on the private cloud, we had integration initially with vCenter, then we added NSX as well. And now we are working to ensure that all of this, as it comes together with VCF, falls in line in terms of the deployment requirements. And given the number of customers which we have, each one has their own set of requirements and flexibility required. Having said that, if you were a new customer or you wanted a very rapid deployment, what we wanted to see was how can we get the top 70-80% of the use cases and do a very quick getting started kind of a deployment in a very easy to use way. So that's where this quick start wizards came in. What these do is that they provide with rapid day zero deployment of the controller, and after the controller is deployed, configuration of the cloud connector, which is basically how Avi controller talks to your private cloud, either the vCenter or the vCenter and NSX. So if we had around 20 plus steps to, let's say, create a vCenter cloud, what we've tried to do is assume defaults and then ensure that you are initially started with provided with just the minimum required to get a good system up and running, which can be used for POCs, for playing around, or could also be converted for production. Right? So it's basically a wizard-like experience and provides the feedback on progress in the UI. So let's just take a quick look at the demo, because that is where the proof of the pudding is. So this is the controller running, on the system, and what we have here is two cloud connectors, one on the vCenter and then on the NSX. So we are going through the vCenter one here. What we do is start with an introduction and the prerequisites. So we give a good checklist of basically the steps which you would want to do before you deploy or connect to the to the vCenter cloud. For example, things like a service account, things like a role, things like credentials to your vCenter. Those things, the IP address, FQDN of vCenter, and then any management or IP addressing requirements. Ensure your network port groups are available and all of that stuff. So this provides you with a handy checklist, and this also links to specific documentation on our .com tech doc site, so you can get through more details. So you can use this as a checklist, ensure that you have met all the prerequisites so that you have a very easy, rapid deployment. Some of this could require you to talk to different teams, so that's why this helps. Next, we start with a cloud, and then we could either use the default cloud, which is packaged, or create a new cloud. We're just using a default cloud, right? Then we ask for a connection to the vCenter, which is where your workloads will reside and where the Avi will be deployed. So once you provide the data, the credentials, the controller is actually trying to validate that, and it goes to the screen only once you have validated. So if there was an issue in terms of the credentials or reachability, it would have not allowed you to proceed. Then we look at some of the data center and the content library configuration, and note that all of this is being done real time. So this is the controller talking to the to the vCenter, getting all the objects and then displaying it to you in real time. So you don't have to figure out or type anything in. You can just select it from the boxes. We look at the management network required for the controller to service engine communication, and with that, we have a review tab. And once you're comfortable with this, you can just click next, and you'll be done. So before that, you could also optionally look at IPAM for IP address management if you were using, for example, an Infoblox or Avi IPAM. And yeah, that's all there is. Once you do that, the cloud gets created and it's ready for deploy, your application to be deployed and service engines to be created. So in a matter of a few minutes, and around 4 screens, what we did was we were able to get to a working system with a configuration connected to the vCenter and ready to deploy our applications. After that, it is all the same. We will ensure that the service engines get created on demand when you deploy your applications or configure your applications, and then provide all the load balancing services. Let's talk about, once we have these applications, some of these require high performance. And performance is something which is always a moving target. Let's look at what we've done in 31.1 to benefit to move that needle over there. So some of the challenges with solving modern applications scale and performance is, performance is always increasing. The requirements are always increasing in terms of some of the factors being SSL transactions, because everything today is secure. Very few customers or applications are comfortable with plain text. So the number of ciphers or types of ciphers are also increasing, and they have different requirements. And then, some of the workloads could be more L4 or L7 throughput intensive. For example, a streaming kind of a use case, or let's say a storage use case where you're transferring large files using S3 protocol. The second is scalability. So as applications grow, horizontal scaling is absolutely essential. So you would want multiple LBs. The challenge with multiple LBs is how do you scale across the same application in active across multiple LBs. So that's something which none of our competitors are able to do. Avi is the only one which provides active load balancing for a single app. And finally, in some cases, the issue becomes how traffic gets pinned across LBs, as we talked about. That is on the horizontal scaling side. On the vertical scaling, if you want to scale, then what you want to do is see how you can leverage more CPUs or allocate more virtual CPUs, and then get to higher NIC bandwidth requirements. And finally, the challenge is always, it comes down to the total cost and the cost efficiency. So we want to ensure that the performance increases while maintaining the cost. And then when you're utilizing when you're doing resource utilization planning, you plan for the worst case. For example, if you have a Black Friday sale coming up, as it is in the next couple of weeks, next week, you have to plan for that, even if that is just a few days of holiday season. And finally, the operational overhead of managing all of this is another challenge when you have multiple load balancers in play. So how do we solve that with QAD? So before that, what exactly is Intel Quick Assist technology? So this is something which we have partnered with Intel. Intel provides the QAT framework and QAT-enabled processors, which provide much better performance for certain for ciphers, for publicly encryption, and for SSL transactions. So both from a SSL TPS as well as a bulk crypto, you get better performance using these processors. Scalable, so you can build your own performance scale based on the number of QAD devices on chip. And then with that, there is also an efficiency in terms of the utilization of the cores. So from an Avi perspective, what we've been doing over the past couple of releases is one, in the previous release, 31.1.1, we introduced support for SSL offload with QAT, with no orchestrated deployments. And then that provided us with up to 6 times SSL TPS performance improvements. So with 31.2.1, which was the recent release, we are pushing that boundary. What we've done is we've ensured that any QAT-enabled hosts are able to be utilized in vCenter and NS6 write access clouds. So you don't have to deploy the service engines manually. It can be just as you would do a non-QAT setup today. All the benefits of Avi's cloud connector automation is available for vCenter and NS6 write access cloud with QAT. And finally, we've also increased performance with bulk crypto offload or SSL throughput, so that you get much better performance with that. Coming to some of the security features, let's talk about PQC. The PQC is a basically post-quantum cryptography, and that is one of the key areas of interest for privacy reasons, for security reasons. So the problem over here is that today, bad actors, threat actors can capture RSA-EC based encrypted data, which are the secure ciphers today, and then in the future, quantum computers may be able to break that old encryption. The problem is that those adversaries could store that data which is encrypted for a long period and then be decrypted tomorrow. So how do you get through with this harvest now, decrypt later attack? So that is where classic versus quantum cryptography come through. Traditional cryptography is good for today. It's hard today to break, but it will be easy for quantum computers in the future. Whereas post-quantum crypto algorithms, they are secure against both classical as well as the new attacks because they rely on different algorithms, different protocols for cryptography. Some of the key elements of PQC, one, of course, is the key exchange mechanism, where the current ECDH mechanism is replaced with better quantum safe algorithms. The digital signatures are newly introduced. Again, these are all NIST-based standards available. And then there is a hybrid mode, which we'll talk about, which combine the best of both worlds. So hybrid cryptography, what it does is it provides you with, think of it as, a belt and a suspender. So a belt allows you to ensure that, you're good in terms of the current hardware, the current classical algorithms, so that is safe. And then when you're using this along with the PQC algorithms concatenated, then you get a second layer of security so that the data is safe both from today's as well as tomorrow's attacks. Right. So from an Avi perspective in 31.1, we introduced PQC capabilities. So we have support for hybrid KEM support. So you can do both classical as well as PQC concatenated. We support these MLDSA signatures, which have become the standard. We support hardware offload as well. So you could use signing from connected to a compatible Thales Luna HSM. And finally, we support this across all elements. So PQC certificates can be configured for the virtual service or the front end, for the pools, or the backends, as well as the monitors. Let's get to the WAF evaluation mode. Avi has a very robust WAF feature set. And Avi has a lot of customers who have already deployed us for non-WAF use cases and who want to enable WAF. Some of the concerns which we heard around that is, one, you need to have a bit of a trial, and there is an uncertainty about what the current attack characteristics are, what the value WAF provides, if you were to enable it. Second is, concern about the resource requirements, because WAF is generally intensive in terms of the CPU. Third, WAF is perceived in general to be difficult to operate because of the lack of visibility or a good way to tune the WAF. So what we've done is to address these challenges, we've come up with an innovative way to provide an evaluation mode for WAF. So with that, what we do is for a load balancing, if you enable evaluation mode for Avi for a virtual service, we can do adaptive traffic sampling, as we'll see in the demo. So with that, we just sample a subset of the traffic to ensure that the CPU utilization doesn't increase beyond a threshold. So with that, even if you're running some production workloads, you can evaluate WAF on that with minimal CPU resource utilization or CPU increase. So this allows you to do WAF inspection with negligible additional CPU, and it's very easy to enable, as we'll see in the demo. So with the benefits which this provides is that you can enable this, you can look at the data coming in, you can look at false positives and then tune that, and then you can run it in detection mode. Again, with that, we also provide a report which gets through a summary, some performance analysis of how much traffic, how much WAF is adding to the, in terms of resource utilization. And finally, from a statistic perspective, what are the top WAF attacks, type of attacks, what are the top IPs from which the attacks came, things like that. Right. So from a lifecycle perspective, as we'll see, what a typical journey would be that you have a load balance, an Avi whip with load balancing enabled, layer 7 load balancing enabled. what you would do is you would enable WAF evaluation mode. We could do the traffic sampling, look at the data, and then flag any of these requests as required, running through the core rule sets, and then create an evaluation report. So based on that, you can fine-tune the profile, the WAF profile, and then migrate to a detection mode with the same virtual service. Then do some more checks, and then finally you can go to an enforcement mode to actually block traffic. Again, let's look at a demo. So this is a virtual service which we have. We call it WAF evaluation demo. And currently there is no evaluation mode enabled on it. What we'll do is that we will enable the evaluation mode over here. So as you can see, we've added a new feature over here, which says try out WAF. That is how we enable WAF evaluation mode over here. It gives you a warning just to ensure that you are aware that you're going to enable WAF on this virtual service. Once that is done, you can see that there is a dotted line to signify that this is still protected in an evaluation mode use case. So if you go to the security tab over here, you will see that we automatically added a WAF policy to this. And we did that in the evaluation mode, as we'll see. You can go and click on that and see that the policy is in evaluation mode, and it is ready to run traffic. So with that, you can continue to send traffic, whether it is production or non-production traffic, to the virtual service as usual. We expect, to do this for over a period of days, a few days, and you will see these logs come in. And this is where I would also like to point out the analytics which we provide for each of these, requests. So each request over here is logged, and you can see the amount of telemetry and data which we provide, which we can collect and provide, on the screen. This is a WAF specific log, but we provide a lot of this for non-WAF cases also. For example, where is the client from? What is the latency between the client and the load balancer, the application server, which backend server serve this traffic, where is the traffic from? So all of this is useful for troubleshooting your apps or figuring out where traffic is coming from. Specifically on the security space, we are looking at what are the signatures which were run through, and if there was a flag, if WAF flagged it, what was the reason? So all of that is available over here for you to look at, then determine in case this is what is expected, or if you think it is a false positive and you want to add a rule exception. So you could do that right from here with on the log itself. So once you're comfortable with that, you can just go ahead and click on the pencil icon over there. Before that, what we're looking at is you can generate a report over here. The report will be generated in a matter of minutes, but then what it does is over a period of, let's say, 7 to 8 days at a minimum is what we recommend. You can, once you have data around that so that you get a good sense of the traffic which is flowing through, you can create this report, and that will provide you with the analytics and the data as to what are the top IP addresses, what are the top attacks, what are the geos from where it is coming, what are the client IPs, things like that, and provide you with recommendations. So once you've looked at the report and you're comfortable with the tuning, what you could do is you can just edit the virtual service again, click on security over there and the policy, and just turn this policy to detection mode. We don't allow moving it into enforcement mode just because it is important that you go through this journey, ensure that you first are aware of what it is flagged, and then in the next step, you can take it into enforcement mode. Just click save, and as I mentioned, in a matter of a few clicks, you have a application which was not protected. You have gone through the journey of ensuring that you look at the data, evaluate it, and then protect it. So coming to the resilience use cases. So as I mentioned, we have a couple of use cases over here, a couple of cool features. One is on the controller, the Avi system upgrade enhancements. So upgrading a load balancer is typically been a challenge because typically architecture means that it's a monolithic architecture. So both control plane and data plane have to be upgraded together. So what if there is a failure? You can't separate those out in a legacy environment. Avi provides a way to just have a controller upgrade first and then upgrade the service engines later one by one. In fact, we go beyond that and we could also say that a certain set of applications, certain set of SEs, service engines in a particular service engine group can be upgraded while the others can be held back for some time. So with that flexibility in upgrades, what you could do is you don't have to do a big bang upgrade, even on the same controller. You could just do controller plus a few application or few tenants, and then do the others as the application teams get ready to that. The second is the visibility in terms of the lack of operational data during the upgrade process. Uh, active HA is not there, so data path challenges come in when you're trying to uh, do the upgrade. And finally, if you have multiple appliances, as most of our strategic customers, large customers are, then doing this box by box becomes an operational overhead. So Avi already, as I mentioned, has flexible upgrades. So we do the controller upgrade first, and then once that is done, we do the service engine upgrade. What we've done in 31.2.1 is take this a step further. What you could do is a dry run uh, of the controller upgrade. So what we do is on one of the follower nodes of Avi, when Avi is running as a cluster as recommended, we will uh, simulate the upgrade from the version 1 to version 2. So with that, we do multiple checks. So it's almost as if you are doing a dry run of the upgrade. You're actually doing all the processes are being instantiated in the new version. And then there is a config migration happening. So with that, all of the config checks are happening, system errors get sorted out, and if there is any issue, you get to know in that isolated environment rather than when you would have done the upgrade. Right? So with that, you also validate any of the resources, and if there are any config limits or system limits which are being breached, those get flagged, with this before you actually do the upgrade. This provides you with a very powerful way to be able to simulate the upgrade and be comfortable, catch any issues, and then do the final upgrade. So with that, your maintenance windows for the upgrades could be reduced. Finally, on the application resilience, which is when you're using instituting the same application in multiple sites using GSLB. So very quick 1 minute overview of GSLB. So effectively what GSLB does is it uses global server load balancing. What it does is it uses DNS as a mechanism to steer traffic to multiple sites. So let's say you have multiple sites and the same application over there. Use cases could be either active or DCDR, A to B. Let's say you want to, or geolocation based, you want customers from, let's say, US based IPs to reach a particular site versus, uh, let's say Europe. So all of that is available and, by the GSLB based or DNS based system. So one of the challenges, few challenges with that in general, when you have complex multiple sites, for example, 4 or 5 sites, is that when the leader site fails, and there's always a leader site, which is the point of configuration for GSLB, then typically manual intervention is required to designate a secondary site as a new leader. Until you do that, configuration changes are blocked, and then there is this operational overhead on deciding which of the sites to promote to a leader. Very relevant when you have large number of sites. For example, we have customers running 6 or 7 sites, and that is where the problem becomes more enhanced. Do note that this is all for the control plane. Your applications will still be able to function because the sites have DNS resolution going on. So it is just that the control plane gets degraded and any configuration of GSLB is not being able to be done. So what we have done is we have provided a way to designate one of the other sites as a backup site for the leader. So if the leader site fails for two reasons, it could be that the leader node itself has failed, or it could be that the leader is partitioned from a network perspective from the other sites. So then there are quorum algorithms which run between all of these 4 or 5 sites. Let's say we have 5 sites, each talking to each other, to determine whether it is an actual event, and then ensure that the designated backup site gets upgraded to the leader site automatically. So with that, you don't have to intervene in these cases to resume operations of configuration. Of course, if there is a larger failure where there is a multi-site partition, multiple things impacted, then you can always fall back to manual leader selection, and then an operator can go in and then designate one of the sites as the designated leader. So the benefit of this, as I mentioned, is it prevents downtime on the control plane. And finally, it really simplifies operation. You don't have to wait for operator to intervene to get systems back and running. So with that, I will hand it over to Chris to go over the container ingress items, and I'll be here to answer any questions. Over to you, Chris.
Yeah, thank you, Abhinav. Let me share my screen. Just checking my screen is visible.
Oh, yes. Perfect.
Okay, so yeah, let's talk about container ingress. And I think this is particularly relevant, especially, since this announcement at KubeCon last week. So first of all, we'll just have a quick look at what we do in the what Avi does in the container ingress space, and what value we provide. So if you look at this diagram here, it's a pretty good sort of architecture and what we see. This is typically what we see across Kubernetes deployments today. We've got a Kubernetes cluster at the bottom there with a number of pods running. I want to expose those to consumers of the applications running in Kubernetes. So to do that, what do I need? I have an Ingress controller, load balancing at layer 7. I'll need a layer 4 load balancer in front of that. If I want to do multi-cluster, maybe I need a GSLB provider as well. If I want to secure my applications, which is, of course, super important these days, I probably need a WAF in front of it. And I definitely need DNS and IPAM. And what we typically see across many enterprises is that these solutions are typically different. I might have a Ingress Nginx Ingress controller. I might have an F5 load balancer, an F5 providing GSLB, something else providing WAF, Infoblox doing DNS, and some other IPAM provider. And although I can string all these pieces together, it can be very difficult. How do I automate all of those things? Yes, I can do it. But I need different Ansible playbooks. I've got to involve different teams. I've got to bring all of that together, and it can be very tricky. And I think finally, one of the biggest problems we see with this kind of architecture as well is visibility. How do I get the visibility from all of these different pieces? How do I make sense of what's happening to my environment from a north-south perspective? Oftentimes, these things are black boxes. And even if they do provide analytics and logging, they don't provide everything you need, such as end-to-end timing and detailed logging. So really, that's where we come in. And our strong suit here is that we provide all of those things that we see on the left-hand side there. We provide them in one single box. We can provide Ingress, we provide Gateway API, we can do layer 4 load balancing. We have a full web application security suite. We provide GSLB, we can do DNS, we can provide IPAM. Now, all of those things that we need to get our applications out to the wider, consumers of the Kubernetes applications, now we have that. We have it in one single box. We've got a single API that we can interact with, so very easy to automate. And because of our architecture, where we've got that separation of control plane and data plane, we have all these little proxies living out in our environment sat in front of our Kubernetes clusters, and they're able to send data up to the controller. The controller has the brain power and the sense to make sense of what's happening, and it can provide really good logging, detailed analytics. And so, no longer do you have a black box in front of your Kubernetes cluster. You've got best-in-class load balancing and best-in-class analytics. Finally, as well, this is, of course, plug and play with VCF. And as we get through this, I'll talk about some of the new integrations we have with the VCF and the VKS platform that's specific to Kubernetes. How do we do it? A little bit behind the scenes of what's going on from the magic behind the scenes. So we know what the controller and we know what the service engines do. The controller is the brains of the operation, and the service engines are where the load balancing is happening. But what happens in Kubernetes? So for that, we have an Avi Kubernetes Operator. That is deployed into all of your clusters. They could be VKS clusters or some other upstream flavor of Kubernetes. And fundamentally, what they do is they translate Kubernetes API calls into Avi calls. So when a developer pushes an ingress, a gateway API, an HTTP route, a service type load balancer, AKO understands that and performs the translation to the Avi controller. And then the controller tells the service engines what to do. So AKO is kind of the source of truth. Kubernetes becomes the source of truth. AKO tells the controller what to do, and the controller tells the service engines what to do. On top of that, we have a multi-cluster operator called AMKO. And what this does is it provides the ability to provide GSLB automatically from within your Kubernetes cluster. So if you have a multi-site environment or even a multi-cluster environment, and you want to do active standby, or any permutation therein and thereof, you can do this with AMKO. And what it's really doing is it's providing the power of GSLB to applications deployed in Kubernetes. And because, it's all native to Kubernetes, you can manipulate GSLB routes. You can do what you need to do from within the Kubernetes ecosphere. You don't have to come out to the controller to do it. Everything is automatic. And again, the source of truth is the Kubernetes cluster, and AMKO is just translating what it needs to do. So that brings us on to our new release. And, our new release is quite a large release. It's got a lot of features in it. We've actually bumped up the major version to 2.1.1. Now, this doesn't mean the APIs have changed. It's just that because of the level of integrations and the items that we put in there, we felt that it warranted a bump in the major release. And why is that? So there's a couple of major things that we have brought in today. The first one is the AKO CRD operator. We'll get into this into a bit more detail, but this allows you to create at a high level. It enables developers, DevOps people to create Avi profiles within Kubernetes, things like health monitors, application profiles, things like that. Now you can create them from Kubernetes. You don't have to go to the Avi controller anymore. Gateway API, we've alluded to this already. Gateway API is the future of Ingress. Ingress API is frozen, so if you're not looking at this today, you should certainly be doing so. We've heard that the Ingress Nginx project is archived. Now's the opportunity to come to Gateway API, kill two birds with one stone. In this release, we've announced support for the CRD operator, of course. We've also got support for Istio as well. So a lot of good things there. And then also from a security perspective, we're bringing in WAF, and the rest of the Avi application suite is now available to secure HTTP route as well. And I'll get into that in a bit more detail as well as we go through. So as I was saying, this release is a pretty major release. On the left-hand side there, you can see sort of Avi controller support. So basically 30.x, 31.x. We support Kubernetes versions 129 to 134. We will support the kind of as new Kubernetes versions come out, we'll bump the point release of AKO to support them. So when 135, 136 comes out, expect to see a 2.1.1, a 2.1.2, a 2.1.3, and that will support those versions. It's the same for OpenShift as well. OpenShift's not on here, but we certainly have support for that. OpenShift versions 4.16 to 4.18, but 4.19 will be coming very soon, and then we'll follow that with 4.20 on the following release as well. So we'll be matching the Kubernetes versions as soon as we possibly can. What can the AKO CRD operator do? As I was saying, we have persistence profiles, application profiles, health monitor profiles, PKI profiles, and that last one there, the route backend extension, that's related to Gateway API, but it just enables you to configure the backend of your HTTP routes. Just give me a second, I've got to get rid of this poll. So lots of new features here. This is also something that we will be constantly updating. So as we go forward, into the next versions of AKO 2.2, things of that nature, we'll be adding more profiles here. So if there is something that you don't see here today, something that you want to have, something that we don't have, please let me know. Let the wider Avi team know, let your solutions architect know, whoever you're working with from an Avi perspective, we can certainly get this in for you. This is going to be a big piece for us moving forward. So we want to get in the, ideally we want Avi to be the Kubernetes load balancer and configure Avi from Kubernetes, and this is the way that we do that. Finally, Gateway API. So we got support for Gateway and HTTP Route 1.3. We got WAF support. We support backend TLS. So this is actually quite unique. There's not a lot of other Gateway API controllers at the moment that support backend TLS. So if you need this with your Gateway API, have a look at us because we can certainly provide that for you. We've got support for MTLS with Istio, and I'll walk through how that works. Of course, the COD support. When we look into sort of VKS and the wider VCF environments, we've got support for VPC, so that works out of the box, so public and private subnets. So, if you're doing VKS or VPC, Avi is a no-brainer really in those environments because it's fully automatic all the way through for VM service, Kubernetes, the whole lot, very automated, best load balancer in there. And then finally, sort of regex-based path matching. So if you're doing path, in your path and the HTTP route, if you're using regex, we'll work with that out of the box and, just build the virtual services as we need to based off the paths that you have in those HTTP routes. So I want to talk about the CRD operator in a little bit more detail. And this CRD operator is actually its own pod. So when you deploy AKO now, you will deploy sort of the AKO pod, and in the AKO pod you have the AKO manager and you have the Gateway API containers. But then you also get a new pod, which is the CRD operator, and it gets its own pod for a number of different reasons. Number one, it's actually doing a lot. It's configuring things directly on Avi. It's managing all of those things. And as I was saying, we're going to add pretty much all of the policies and all of the things that you can do from Avi over time. That will get added to this operator. So that's what makes it have its own pod. It's really easy to install. It's just, you install it the same way you install. It's part of the AKO install, part of the AKO Helm install. So it just goes into the cluster natively. There's just an option to turn it on and turn it off in the values file. So pretty easy to use. It can track all the statuses of the objects that are deployed. So, you can get details of what CRDs are there, how they're being used, and if they're accepted or not. And it also supports multi-tenancy. So, it can manage namescope, as you see here, namespace scope resources, keeps them separated from an Avi tenancy perspective as well. So that's why it's its own operator. Just to give you an idea, a quick look at what the sort of CRDs look like. You can see here that this is the health monitor. And we've pretty much extended the entire, in this case, you can see here the HTTP health monitor. We've pretty much extended the entire Avi API for health monitors to Kubernetes. So pretty much anything you can do on the UI here, you can do from this Kubernetes YAML file. So now you're a developer, if you're a DevOps persona, no need to go talk to the team running the Avi controller. You can do it yourself. It's very easy to use. And then you can use RBAC within Kubernetes and on Avi to, make sure that the developer can't do anything more than they should be able to do. But at the end of the day, you're speeding up deploying applications from Kubernetes. And at the end of the day, that's what we want to do. We also support ping and TCP. So you can do the same thing for the other health checks here. And again, as I say, we'll be adding more to this as well. So HTTPS and things of that nature we'll be adding in here as well. An example of the application profile. So this is a really good one too. It's something that I've been asked for a lot. But again, we're extending pretty much and you can't see it all here because there's a lot of configuration options, but you can extend the entire API for the application profile. Initially, it's just HTTP, but more will be offered as well. We'll start offering layer 4 profiles, things of that nature here too. So you can turn off X-forwarded protocol, keep alive, all of that kind of thing. You can do that all from within Kubernetes, same reasoning as before. So really a powerful tool. This AKO CRD operator is really quite a powerful tool if you're using Avi and Kubernetes. Allows you to do a lot of things. The next piece is relevant if you are using Supervisor today. So if you're using VCF and you're using Supervisor, this has been called numerous things over the years, TKGS, vSphere on Tanzu. Today we call it Supervisor and vSphere Kubernetes Service. But what we've introduced here, and this has come in as part of VKS 3.5, is that you can now deploy Avi from supervisor, AKO from the supervisor into the VKS clusters. How does that work? So picture this, we have a supervisor cluster. We've deployed a couple of namespaces. We've got a couple of VKS clusters deployed into those namespaces. And fundamentally, what I do is there is an add-on config command that will, you basically use key value pairs labels to tell the supervisor which VKS clusters you'd like Avi to be installed into. You create an add-on config for those those VKS clusters, and then the supervisor will manage that AKO and put it in there. So it's a very natural thing from a supervisor experience, very native, sorry, from a supervisor experience. It's a very sort of supervisor way to manage your VKS clusters. The other nice thing about this is because it's packaged with the VKS, vSphere Kubernetes Service, the AKO, you don't have to worry about lifecycle management because whichever AKO is packaged, whichever VKS you're using, that will work, guaranteed to work, guaranteed to be tested with those VKS clusters. So you don't have to worry about lifecycle management and software management, things of that nature. Again, it's kind of taken care of for you. The new CRDs that we brought in for Gateway API, from an HTTP route, we now support the Health Monitor CRD application profile, PKI, persistence, and the Layer 7 rule. The Layer 7 rule, if you've used this before, is used on we use it for Ingress today. But what this does is it allows us to kind of apply all these security profiles on the right-hand side there. So HTTP route, you can secure with WAF. You can enable bot detection, malware detection via ICAP, and this is how you can do that backend TLS as well. So really you can sort of secure WAF from the front end, do backend TLS, front end TLS, put in bot detection malware. So if you've got any applications hosted on the internet or you need to protect in detail, this is a very easy way to do this. And again, it's all very native to Kubernetes. You can do it from Kubernetes. Finally, want to talk about what we're doing from an Istio service mesh perspective. So it's quite interesting. KubeCon this year was there. We obviously heard that Nginx announcement. Service mesh seems to be coming back again, specifically Istio. Ambient mesh is, to kind of solve some of those issues that perhaps sidecars caused within Istio and service mesh. So it certainly seems to be coming back up. Gateway API can be used to front end Istio service meshes. If you look what the Istio project are doing, they are sort of deprecating Ingress Gateway in favor of Gateway API. And so what we can do now is we can sit in front of your Istio-based service meshes, load balance to the workloads behind it. We work with MTLS. And then, of course, we can apply the WAF, bot detection, HTTP security policies, you name it, in front of that. We understand the Istio certificates. So Istio will rotate certificates every 24 hours. We understand that. So we'll also rotate certificates on the service engine every 24 hours as well as Istio does that. So it's a very native integration. So that's it for the Kubernetes side of things, but just sort of a final kind of key takeaways from what we're delivering. So both of these releases are pretty large and lots of good features enabled in them. Just to highlight what we've talked about today, you've got simplified Avi deployments with the quick start wizard. So, you're significantly reducing the time it takes to deploy the Avi Cloud connectors now. Just kill my poll. We've significantly increased TLS performance with Intel Quick Assist technology. So this is really putting us on par, if not more, so then, dedicated hardware now. I really like this new WAF evaluation mode. I think it's really quite clever, the way that we're using spare resources, spare CPU cycles to learn what's happening from a web application security perspective. As Abhinav mentioned, WAF is quite hard to manage, quite hard to understand. This really helps with that. And it's quite a unique thing for us, for Avi. So, while your SEs aren't using resources, we can learn what's happening. And it's almost like a free WAF learning mode. And then tie that into our PQC, the security, what we're doing from a security perspective is really kind of underlined there. The GSLB pieces as well. And I've just harped on a lot about Kubernetes and increasing the developer experience with all of the new pieces we have there. And then finally, the simulated upgrades, the dry run to help people upgrade and no impact. I think that's it for me.
Yep, I can take over here with just these final slides. So, yep, thank you guys for attending part three of our webinar series. I want to draw your attention to our enablement path slide. So you have all just attended a webinar, but we also have many other courses, many other labs that you can participate in to get kind of hands-on approach to the Avi product. Um, Additionally, Chris, if you jump to that next slide, I just have some links here. So when these slides go out via the email, you'll be able to click these, and each you see part one, part two is highlighted. You can actually access our on-demand videos through that link. Thank you all for attending. On your way out, there's going to be a little poll just to collect some data from you guys. Let us know how we did, if we can improve anything. That would be greatly appreciated as well. Thank you all.
Thank you.
Thank you.